Okay, so I'm going to do 4.46 for you on lesson 4.5. And this one surprised me a little bit. I learned a little bit on doing this one. I can learn things too, right? So here was our function. And I noticed right away that when I started to look at our horizontal asymptote and our vertical asymptote, my vertical asymptote, when I factor this denominator, is an x times a 3 minus x, which would lead us to think that immediately we had a 0 and a 3 for our horizontal asymptotes, vertical asymptotes, but we also had a 0 of 0, and the 0 of 0 and the vertical asymptote of 0 will cancel each other out, and we will get a whole. So instead of a vertical asymptote at 0, we will get a whole at 0. And because there's a whole at 0, that cancels out our only 0, which was right here at 0. And so therefore we have no zeros. And if we let 0 go into every x, we have 0 as our y-intercept also, but we already have a whole at 0. So we're not going to have a y-intercept either, because when I plug in a 0, I get everything goes to 0. So we should not have a y-intercept either, unless, I'm just trying to think, if I crossed out that 0, once I cancel that out, it is going to have a y-intercept. Like I said, I'm learning things with this one. So I'm going to go ahead and cancel the x out of both the numerator and the denominator, and that is going to give me a y-intercept, which is good because my graph has one, and I was trying to figure that out, but I had not canceled this numerator x and the denominator x. Now that I've made a note that my domain has got to exclude both the 0 and the 3. So now I'm able to cancel it, cancel out the x on the top, cancel out the x on the bottom. Okay, and now when I plug in a 0 to get my y-intercept, I will have a y-intercept of 1. So y-intercept is 1, okay, and we have a whole at 0, and so I graphed this for you. Okay, so even though we do have a crossing at the y-axis, it's not really there. Okay, so here is a graph, and what I did is I plotted my vertical asymptote of 3, my horizontal asymptote, because my denominator power is a negative x squared and my numerator power is a negative 3, the denominator degree is greater, and therefore I will get a horizontal asymptote of 0, just like my parent function. And so now I have a horizontal asymptote that it is approaching at 0, and I've got that on the graph. I have got no x-intercepts. I have a zeroed out, in other words, I've got a hole at my y-intercept, and this is what my graph should look like. Okay, so what I did when I first graphed it is I actually had this coming down a little bit lower because I had forgotten to cancel out the x and the x. But then, as I played with it, just to see what it looks like, because, you know, I like to understand things, is I plugged in a point that was very, very close to 0. I plugged in 0.01, and I thought, let's see what it acts like when I plug in 0.01, because it can't go to 0. I can't plug in a 0 because that's an excluded value. So I plugged in 0.01, and this, when I square a hundredth, I get 10,000th. So it's very, very small. And so I wind up effectually with a 1, a 0.03 over a 0.03, or so close to it that it doesn't matter. So it stayed at 1 as it crossed the axis, which made sense because that's where my y-intercept would have been if I hadn't had it zeroed out. So now it approaches that asymptote as it goes over there, and I plugged in some points. Now once I plugged in this point, I plugged in some points over here to see what it did. Notice it is hugging the asymptotes here, and then since it went down out low, then it had to come in high. I knew that, but I wanted to plug in some points over here to see what it acted like as it got close to the hole. Okay, so then it continues on and goes and hugs the horizontal asymptote of 0. So to me that was an interesting one, and I enjoyed graphing it. And I'm going to show you the graphing equation check of it here shortly. The graphic calculator. So here is my function that I put into the graphing calculator, which I will screenshot for you shortly. And here is the graph. Notice it crosses the y-axis at about 1, and it approaches the asymptotes as we expected it to. Alright, so now we're with problem 56, and we're going to start wrapping this up. I've got 3 more problems on the boards. Okay, when we start looking at the vertical asymptote, we can see that the vertical asymptote is going to be at -2. Our 0 is going to be at +1. Okay, so our horizontal asymptote is going to be at 1 because our 2 degrees are the same. So our horizontal asymptote, because we have an x over x, is 1 over 1, or just 1. Okay, so that means that when we start to graph this thing, I can draw something similar, close to a straight grid. Okay, so vertical asymptote at -2. So we'll put our little dashed line here at -2. Our 0 is at 1. Our horizontal asymptote is at y is 1. So it's going to be like this. Okay, so we have 1 x-intercept. If we plug in a 0, then we get a y-intercept of -1/2. So our y-intercept is -1/2, so we'll put that about right there. Okay, remember our domain has to do with our vertical asymptote, so we have to exclude a -2. But this is pretty simple to graph because I only have 1 vertical asymptote. I know that my graph has to go through here and it has to go through here. So I'm gonna hug my asymptotes, and I'm gonna go out in this direction. And since I went out low here, I'm gonna come in up here high and then hug my asymptote over here. So that should be the graph of that one. That's a pretty simple one. And so I'm not even going to put that one on a graphing calculator. That one should be exactly like it looks. Now on a test, I would want you to maybe plug in a point over here. So plug in a -3 and make sure that you do indeed have a positive value. If we plug in a -3, then we'd have a -4 on the top, and a -3 plus a 2 would be a -1, and a -4 over -1 is a +4, and that's what we are expecting it to be, positive. And it should never go down below 1 because there are no more zeros over there. Remember, in the big scheme of things, vertical asymptotes are the strongest. Zeros are stronger than horizontal asymptotes though. So this one is finished. The next one we're going to do is number 66. Sorry about that glare. It's getting into my eyes too because the sun is going down. Okay, so when we factor this denominator, we're going to have an x plus 5, x minus 3. And neither one of those are going to cancel out my numerator. So I have a horizontal asymptote, a vertical asymptote at -5 and at +3. I have a horizontal asymptote because the denominator degree is greater than the numerator degree is going to be at 0. So my horizontal asymptote is at 0. My 0 is from the numerator and it is at -2. And my y-intercept is what's going to happen when I plug in a 0 for the x. And for my y-intercept, I would get a 2 on the top. And on the bottom, I'd get a 5 times a -3 or a -15. Okay, so -215 is my y-intercept. -2/15 when I plug in my zeros for my x. And so my domain is going to go from -infinity to -5, not including the -5, then -5 to 3, not including either one of those, and then from 3 to infinity. So let's give this, let's see if I can draw my grid. Okay, so let's put in all of our information. We have a vertical asymptote at -5, which I'm going to put right there. And so we'll draw our little vertical line there. And +3, we'll say that's right there. Okay, so my two vertical asymptotes. Okay, I have a horizontal asymptote at 0, so it's going to go right through my x-axis. I have a 0 at -2, which we'll put right there. And a y-intercept at -2/15, which is very tiny negative, right? So we'll put it right there. Okay, so this one is going to have two asymptotes, so we should, here, we're crossing, we have a 0, which is stronger than our horizontal asymptote of 0. So we're thinking this thing's going to come down, but it has nowhere to go up, so I'm thinking that it's going to come down and hug that asymptote. Here, since it came through, it's going to most likely go up. And again, we're going to check this with some points. But since it went out up to +infinity, it's going to come down below and should stay below that axis all the way to the left. And then again, since it went out low here, it should come in high and go out to +infinity there. So that's just my best guess, but I have not put in any points other than the ones that I figured out were my zeros and my y-intercept. So just to check, let's plug in, say, 2 to make sure that it's slightly negative there. So when I plug in a 2, I'm going to get a 4. And then I plug a 2 here, we're going to get a 4 plus 2 times 2 is 4 minus 15. So I'm going to get a 4 over 8 minus 15 is a -7. 4 over -7 is a fraction less than 1 that is negative. Okay, so a little bit negative. That confirms that. Now I'm thinking that when I move to the left here, I'm going to go positive. So let's put in -3 and let's see what happens. If I plug in a -3 up here, my numerator is going to be a -1. Okay, and then I plug in a -3 down here, and I'm going to get a +9 and a -6 and a -15, which will be negative. And I'll have a negative over a negative, which is a positive, and so it does go up towards that. So I put in a couple of points, and I am convinced that this is the way that this graph is going to look. And since I'm losing my light, I'm going to go on to the next problem. So I'll give you a good picture of that one. Okay, so last problem is number 74. okay? And on 74, we're going to have our vertical asymptotes are going to be at -5 and +5, because x squared minus 25 is going to factor there. And then our horizontally, we can pull out an x. So an x goes all the way across there, so we're going to have an x times an x squared plus 2x minus 3. And when I factor that further, I get an x minus and an x plus, and we're going to say plus 3 minus 1 will give us this. So we're going to have zeros are going to be at 0 and at 1 and at -3. Okay, now on this one, notice we do not have a horizontal asymptote. We have our numerator power is greater than our denominator power, so we're going to have to do some work there and get a horizontal asymptote. The first thing I'm going to do, a slant asymptote, is I'm going to make sure I have everything else that I can possibly get. My y-intercept, remember when x goes to 0, my y-intercept is 0. So that's a piece of information that I need to put in there. And I have zeros, and I have my y-intercept, I have my vertical asymptotes. So now there's that board. Go ahead and get that one down. And the glare is getting down low here as the sun's about to go down. Okay, so now I'm going to go to another board and calculate your slant asymptote. Okay, so we're going to long divide x cubed plus 2x squared minus 3x, and we're going to divide it by x squared plus 0x minus 25. Okay, so my daughter's being silly. Okay, anytime, so x squared goes into x cubed 1x time, so we're going to put this all the way over here, and then x times x squared is x cubed, and then x times 0 is 0x squared. My family is getting very bored in the car, so they're doing all kinds of funny things here to distract me. So x times the -25 is a -25x. Okay, so we're subtracting, so we're going to change all of the signs. And we're going to
crystals are heating. Scotty, work it out. I'm giving it a shot, Captain.
Okay, so now this one's going to cancel. This one is going to be a 2x squared. And this one is going to be plus 22x. Okay, so now we've already got our x one. Now all we have to do is find our constant. So x squared goes into 2x squared 2 times. And remember, once we have our linear portion, we don't care about that remainder at all. So we're going to have y is equal to x plus 2 is our slant asymptote on that one. Okay, so now we're going to put it all together and finish up this graph. Okay, so we have a slant asymptote. Y is x plus 2, and that's going to be a y-intercept of 2 and a slope of 1. Okay, so here we go with our slant asymptote. Y plus 2, y is equal to x plus 2, so here's my 2, and then I'm going to go up 1 and over 1. So up 1 over 1, up 1 over 1, up 1 over 1, and that is my slant asymptote, like that. Okay, and then I have vertical asymptotes at 5 and -5. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. And so I'll put in my vertical asymptote and my vertical asymptote there. Okay, and then I have an x-intercept of 0. And I have zeros at 0 and, excuse me, I said an x-intercept. That was supposed to be my y-intercept, which also turns out to be my x-intercept at 0 and 1 and -3. So remember, I'm getting all this information off of this board, okay, which we had already looked at. So now I have graphed all of that here. So we have 3 zeros, and one of them is also my y-intercept there. So this point right here, remember, that is not a point on the graph. That was the 2 of the y-intercept of the slant asymptote. So, okay, so this is an interesting one because this one actually is a good example of a zero that is stronger than its, in this case, slant asymptote. So basically it touches here, but instead of following up to curve up to its zero asymptote, to the horizontal asymptote, or in this case the slant asymptote, it's actually coming down somehow. We're going to have to get some more points in here to see what actually happens here, but I'm thinking it pops and then continues to go down in this direction. So I'm going to throw some points in just a minute, but then way down here, since it went out high, it should come in low and do something like this. Then over here, since it went out low, it should come in high like that. Okay, so I'm going to plug in some points to confirm that, but that's what I'm thinking it's going to do. So here are the factors at the top of the page, and I plugged in a -4 and got a positive 20 over 9, which is a little over 2. I plugged in a -2 and got a -6 over 21. And then I plugged in a 0 and got a 0, of course. Then I plugged in 4 and got a negative big, very big. I didn't even bother to calculate it. So, based on those points, I am now going to erase this part right here, and I'm going to count down just a little bit below. Okay, and now that should be an accurate graph. Down here, it's making another little, because of the asymptote going there and there, it has a little squiggle down there, and it's coming out up here, and that is now looking like what it should be. And notice that in this case, we had the zeros were stronger than the asymptote, and we crossed the asymptote and did not follow that. Now the asymptote is still there. You can see how it changes the way this acts down here, but these zeros actually went right over the asymptote and did not follow it. So I just realized that in all of my starting and stopping, I had that last little part completely sideways. So I wanted to show you the graph as it should correctly appear, with the 2 vertical asymptotes at -5 and +5, and the slant asymptote being crossed by the zeros, who are stronger, and there you have it, correctly oriented. Sorry about that. Hazards of the road. Thank you for bearing with me as I was traveling on the road. We have finished 4.5, which is the last section that is on your test, coming this Tuesday and Wednesday, depending on which class you're in. And this is Mrs. A, and may God bless your day.